Hi, day everyone. Finally I got a better app. Previously I've uploaded the first video where I've actually used a whiteboard um, a whiteboard app for the first time. But then it was troublesome because the way it was sensing the whether I was using a finger or this tablet pen, it was still not easy to use either way. So now I've downloaded this app. So now on this video I just want to show you how to derive certain derivatives of some functions from first principles. um, I've seen that most learners struggle with this one. I'm just gonna write here. Oh sorry, let me select a pen here, and then white I think would be fine. Yeah, white is fine. Let's see. Number one, this one, f prime x equals to square root of x. um for some it will be easier to do, but then most people find it hard. But then I'll simply show why most people find it harder to do, and it's understandable. I'm trying to move this here. Let's see here. So I'm just gonna write the solution here. Okay, we know that from first principles the equation is as this way. It says, oh I'm sorry, I always forget selecting the pen here. Yeah, we know that from first principles the equation is this way. F prime of x equals to the limit where h tends to 0 of f of x plus, oh the x now doesn't appear as x. Let's see, I'm trying to do undo. It's f of x plus h minus f of x all divided by h. That's the formula, right? So here it's not a problem, right? This is not a problem. Let's just substitute here. Remember, we still write the limit when h tends to 0. Now for f of x plus h, remember where there is x in the equation, the original equation, you just substitute with x plus h. So what is f of x plus h? It will be square root of x plus h. In other words, I've substituted with x plus h where there was x in that equation. So this is minus f of x is simply square root of x, right? Then divided by h. So now I'm just gonna move this let me just move this here, right? So now I'm not gonna forget selecting the pen again. Fine. Now this is equals to, now here comes the tricky part. Most learners stuck here, like they don't know what to do right after here. And obviously if I substitute h with 0 right in this equation, what I'm gonna get here, let me just show you what I'm gonna get if I substitute h here. If I'm gonna substitute h here, then this will remain as square root of x only, and then minus, there's no h this side, and then that means that is square root of x minus square root of x, which becomes 0 as the numerator. The denominator is also gonna be 0, so we have 0 divided by 0, and in mathematics 0 divided by 0, it's indeterminate. You can't really determine it. So that's the problem, a big lot of problem. So how can one actually do it? In fact, you have to be clever around it. Okay, I'm just gonna I want to remove these equal signs here. Okay, now they're fine. You have to be clever to realize that you have to actually do this. Or back to my habit of forgetting to select back to this pen thing. Okay, so this becomes limit of h going to 0. Again, I'm just gonna write what I have written initially: x plus h minus square root of x all divided by h. Now here comes the tricky part. Here I'm now going to do this tricky thing here. I'm going to multiply by what I normally call a special one. Remember, in mathematics, if I multiply any number by 1, the value of that number won't change, right? So I'm going to multiply this whole thing by special one. When I say special one, I mean it this way. I'm actually going to do it this way. Let me try to move this thing here. No, I don't want to select this. I just want to do this. We need to reduce in size. Yes. So now I'm gonna select the pen. Yeah. So now I'm gonna multiply by a special one this way. This special one, I think I'm gonna write it using a different color. This is a special one that I'm talking about. It's square root of x plus x. There is the problem again. I don't want this. What am I doing? Yes, it's square root of x plus h. Now I'm just gonna write the same term that we get on the left here, on the left of this multiplication sign, but now I'm gonna write a plus here instead of a negative, because this brings me to multiplication of in fact, this is what we call a conjugate in mathematics, so that I get a difference of two squares. But remember, when I said a special one, I'm actually going to divide by the same thing above. There is my challenge with writing x's here on this app, but then this app is much better than the previous one. So this is plus root x. So this is a special one that I was actually talking about, because anything that like any fraction that we have, whereas the numerator and the denominator are equal in value, it's all equal to 1. That fraction is equal to 1, right? Because they can actually cancel. But now going back to my white color, so now this whole thing is equal to this. I'm just simply gonna do some multiplication there. Now I have to write h carefully. Yes, when h tends to 0, I'm just gonna reduce this in size. Actually, let me try to move it as well up here, right? So now selecting the pen white, then I'm sorted. So now I'm gonna multiply these things here. Now when I multiply the numerators there, it's not a problem, because it leads me to a difference of two squares. Now because they're the same terms, different signs, so they are conjugates. So now I know that I'm gonna remain with a square of the first term. The square of the first terms. This x is ugly in this way. Let me try to write it well. X plus h, then all squared, right? Then minus now the square of the last terms. Remember, the middle terms are just gonna cancel out. That's why I didn't write that. I hope you get what I'm saying, right? So this is square root of x squared, all divided by h multiplied by square root of x plus h, then plus square root of x, right? So now this will I be able to move this while it's in? No, I can't. So now I have to do this, then move this whole thing here, right? So now this becomes this way. This is equals to, again, the limit when h tends to 0. Oh no, that doesn't seem as, yeah, this is like 0. Yeah, h tends to 0 of what? Now the square is gonna cancel the square roots. I'm just gonna remain with x plus h minus x as my numerator, all divided by, even if I don't multiply out the denominator, it's fine. then x plus h, this h again, h plus square root of x, right? Then this is equals to, now this is what's gonna happen. This is the limit of h going to 0. I'm just gonna move this again. Let's see now. Just like in the pen again. So now this becomes the limit when h tends to 0 of, I'm just gonna simplify the numerator. X minus x is 0, so you're gonna remain with h only. So this is what's gonna happen. Now my h is, okay, this, it's h over h into square root of x plus h minus square root of x. Yes, so this is equals to, the h are gonna cancel, so I'm gonna remain with limit when h, this is not, this doesn't look like h for sure, so I'm just gonna move this up again. I feel like the space is way too small, right? But it's fine. So now this is how it's written. I'm just gonna select the pen again, white, fine. So again, limit when h goes to 0, the h are gonna cancel, you're gonna remain with 1 as the numerator, all divided by square root of x plus h minus, nah, I've made a mistake here, it's plus, where do, it can't be minus here guys, it's plus, so square root of x. Otherwise I was gonna have 0 as my denominator, I'm gonna have to substitute for 8. But then also remember here, this denominator was plus all the way since I've introduced that special one. So now I can substitute the h. In the numerator there's no h, so the answer is just 1. So I'm no longer writing the limit because I've substitution h. In other words, it's this expression getting closer to 0. In other words, not this expression, basically the h approaching 0. How will this expression turn out to be, right? So for us to find that, we have to substitute h with 0. So now when I substitute there, I'm gonna get x plus 0 plus square root, oh, it's ugly again. Okay, let me just move this again and again. I've been moving it. Okay, so here's the pen again, white color. So over this, so it's 1 divided by square root of, oh, I've made a mess here, oh, again it's square root of, yeah, square root of x plus 0 plus square root of x. So basically you'll get 1 over 2 square root of x, and that's the derivative of root x. So we are done guys for this part. So now, yeah, I'm just gonna stop here. You're welcome to send any more questions guys. I'll be doing a lot of several problems and other techniques and other derivations as well. So yeah, so this is it. So finally I'm done. Let me do this. I have to stop here.